So I'm very excited to introduce our first speaker, Dr. Erin Cortus from the University of Minnesota. Erin is an associate professor and extension engineer in the Department of Bioproducts and Biosystems Engineering at the U of M. Her past and ongoing projects have included measuring the air quality impacts of different manure management practices in dairy, poultry, swine, and beef. So she's across all species, not just pigs. And she has worked on biosecurity and sustainability metrics as well. So the broad mission of Dr. Cortus's program is to work with producers and communities to understand and continually improve the quality and productivity of livestock environments. So very excited to hear what Erin has to share with us today.
Well, thank you for having me. Is my mic coming through okay for everybody in the room? Great. Happy to be here. I think we can all appreciate the power of this little tiny bottle that's in Nancy Bullborman's hands. Nancy is a PhD student who's been working with us on this project for years and is really the key manager behind this database. But I think we can all appreciate the value behind this little bottle, right? This little bottle of manure. From this little bottle, having it analyzed, that spells out how we can use those nutrients in that manure very effectively, agronomically and frankly economically as well. But what do we do when we don't have that sample? That's what this database is really about. What do we do when we don't have this sample to base our decisions on? So this project is about accessing past and present US manure nutrient data using something we've been creating over the last couple of years. So I'm going to go through the beginning, the current, and then potentially the future of this database. In the beginning, how we started this is that we know that there are manure book values. We have different books, the ASABE standard, or American Society of Agriculture and Biological Engineers standard, and then also the Midwest Plan Service standard. And through these two textbooks and some literature as well, we have some standard values that we've been using for manure. And in the absence of that little tiny bottle, right, of the manure that we want to use, we have to rely on these book values to develop manure management plans, design manure storage facilities, and frankly just get to establishing some best land management practices. In recent years, per some of Chris's introduction too, with some of these life cycle analyses and modeling that's been going on, manure is a big piece of that. And therein too, we are in need of manure composition data to inform a lot of these calculations. And the more specific we know, we can make that data to a region, to a farm type, the better or the closer we feel those estimates can be. So with ManureDB, or Manure Database, that's the short form for database, ManureDB, the goals here are to design and implement a database first and foremost. So the goals are to combine manure analysis results from around the US and ultimately ensure it's scalable and dynamic. The concept behind this project is that as researchers, we'll take manure samples here and there for different projects, send them in for analysis, and we have a limited amount of data. But every year across the US, labs are analyzing thousands and thousands of manure samples. And we recognize that those analyses are, the information is property of the lab, but also property of the customer. But how can we use that information to inform the greater good, as we really like to say? This is an example map of labs across the US that participate in a specific program, the Manure Analysis Proficiency Program. And it's a program designed to test for labs to demonstrate that they use good lab analysis techniques. But even just the distribution of those labs show the spread. And if we could pull manure sample data from across the US, that already gives us a much broader set of information. So the second part of this project then is how do we provide that data publicly? And this is really just a mock-up of where we hope that this can go. But it's to provide up-to-date aggregated information on animal manure composition in user-selected terms, spatially, temporally, and by animal system source. With this in mind, there is a project team that's been working together on this, that is between the University of Minnesota, CFANS and Extension, as well as the Supercomputing Institute, and then with the Minnesota Department of Ag participating around or supporting this core project team. In the middle, we do have a stakeholder advisory group, which encompasses commercial manure labs, alternative energy groups, and engineers, researchers, and regulatory staff as well. Part of moving forward with this project, one of the questions, one of the concerns, of course, is the use of data. And so through this project, we have a data use agreement with the lab, and to alleviate privacy concerns for samples or the data that we receive, we don't receive any customer names or addresses with the data that a lab supplies. Only the first 3 digits of zip codes associated with samples are part of the database. So that gives us some ability to scale the data that's in the database geographically, but we're not getting to the nearest farm by any means. And even that being said, we've incorporated a function that there needs to be at least 5 samples for an average to be presented, within a region or within a type, so that we can alleviate some of that, to help protect some privacy. There's umpteen different facets of that data that we would love to have with every single sample, right? If we receive a data line of manure, we would love to know, as best we can, where it came from. We would love to know if it was treated with anything, if there was bedding incorporated in that manure. But we know that that's rarely going to be the case. Every single lab has different sample submittal forms. They collect different amounts of data, and then we're also limited to what people actually fill out in a form. So this is my first plea to all of you that are in the room that happen to submit manure samples. Please fill out your sample submittal form to the best of your ability, to the most detail possible, because it does help build up some more specificity in this database. So that brings us to where are we? Well, the database is now live. We call it a soft launch. We're not shouting it from the rooftops yet, because of course we still have, with any software, a couple bugs probably to work out, and some, we found many of them, but I'm sure there are a few more to find. But we have soft launched ManureDB.umn.edu. Within this particular web page that is soft launched, like I said, we have ability to look at manure by animal type. There's ways to look at it by the year analyzed, and we have a few other ways to break down the manure samples that are in that database, and ultimately show what are the averages, medians, and other statistics about the data in there, as well as what are different nutrient compositions. We have lab agreements with 14 different labs across the US, and then there are some more verbal agreements with other labs pending signatures. As of last week, there were 422,000 samples in this database, which the majority, we have a known location associated with that sample. Because, every lab analysis for manure, you're usually at least getting NP and K, right? And so the number of analytes that we have in there is an exponential function of that. And we have data from almost every US state, plus DC and Puerto Rico. I believe our holdout is Alaska. And we've figured out a way to try and get around that, but we don't have it in the database yet. What's been interesting as we've been pulling data in from different labs, and they've been sharing their data with us, what started out as a database for pigs, dairy, beef, poultry, has expanded to a lot of other different animal types, because it isn't just livestock, right, that need their samples analyzed. You'll see with swine, we've broken the swine down into multiple categories as best we can based on the data that's there. But you'll also find on here rabbit, bison, except have some elephant samples. From my perspective as an extension engineer, this is exciting, because it's about once a year that I get a call asking, do I know what the manure composition is for bison or some other less popular animal type? So even though that might not be part of that immediate public-facing front, we still are starting to gather some more data that can be useful in many ways. There are also other amendments, right? Other ways that nutrients are collected and then usually ultimately land applied. And so part of our discussions, ongoing discussions, are what of these other nutrient amendments are or should be part of this database, right? What's that tie to livestock production that becomes our cutoff point? So thus far, if we can tie it to livestock production and it's land applied in similar fashions to manure, we are at the present time collecting them in the database. Then as Nancy in particular has talked with all of these different labs that are sharing samples, the number of analytes that are measured is well beyond the NP and K. And I think what's exciting from, again, the area that I work in, as we look at some of the sustainability, is being able to garner some more data on alternative forms of manure, like digestate or separated solids that might accompany digesters, for example, or different measurements like biomethane potential that are needed in the production of, or in the design of digesters. But what do we see in this database now if we look back in time? So if within some samples that we pulled from the database between 2016 and 2022, for samples that were labeled as swine samples, that's all we knew, it's from a swine farm, or swine finisher, liquid manure samples. If we look at the total Kjeldahl nitrogen data, what's shown in the blue dotted lines are some of these book values. This top dotted line is the book value from Midwest Plan Service 18 book for deep pit grow finish barns. And then down here is the book value for farrow to finish barns from that same source. Now, obviously, a big spread in just even book values, but as we look then at the data that's in the database, 774 samples for this particular set. Over time, there's been some change over time between 2016 and 2022, not a huge change. But what's also nice is that the database enables us to look at what is this variability. Now, swine finisher, those are very broad categories, correct? If we're just talking about the states of Illinois, Iowa, Minnesota, and Wisconsin, we can make some general assumptions that most of this is probably deep pit manure, right? But we don't necessarily know for sure. And that's where I'm saying the more we can fill in these sample submittal forms, the better. However, knowing even just this variation, I think moves us a long ways, right? And it gives us also some bounds that we can work within when we start to look at modeling, for example, and estimations. The same type of picture is presented for phosphate, P2O5. Now, there's a fairly stark difference between what we have in Midwest Plan Service as far as book values for phosphate levels in manure, for deep pit manure, and even farrow finish manure, compared to what is present in over 8,000 samples between 2000, now this is going even further back, and 2022. Within this period, the phosphate levels have changed quite a bit, and even at the start, they weren't necessarily as high as what the book values were suggesting. But it's gone up and down, and I think many of us in this room can recognize some of the reasons for some of those changes, just based on diet formulation, phytase, etc. But now we have some proof, right? Now we have some documented examples from commercial labs, from on-farm examples of what these changes look like over time, as well as that variability within samples, the variability between samples. as normal, the potassium is kind of a boring picture, right? Potassium is like the one we always ignore, but and some data over time looking at comparing the book values shown in the dotted lines over dotted lines, and then this is 2016 to 2022, 4,000 samples in here, and the average or the median is quite a bit lower than those, and then there we have some spread as well. With the manure data, as you can imagine, and the variability, we are medians versus means for this data because of some skewness data. So we are presenting, or the database, I think, still presents a mean, but as we move forward, there is going to be a focus on median data for these manure samples. So these are examples of how, with the database, we can start to pull out data over time. Are all of these features user ready right now? Not quite, but what there will be is an opportunity for users to select a set of parameters. We liken it to NAS stats, right? Select a set of parameters and then download a CSV or download a data sheet for the type of information. Another example of where this can kind of go or look at, now this is a pulling from the dairy industry, but the same could be done in other species. You know, is there a difference between areas? So this is an example between New York and Wisconsin dairies, and looking at the N, P, and K values. And on the N, total N side and phosphate side, not a lot of difference between the two states. Some difference in the variation, but when we look at the potassium, there we start to see a little bit bigger of a difference. Now, of course, with different areas, you have different numbers of samples, and that factors in, of course, into the data, but it's still more data and more specificity than we've had before. Another example where we hope to take this is diving even deeper into different manure types. So with this example, looking at dairy manure types between 1998 and 2022, we can look at digestate samples, which have a relatively high total nitrogen and P2O5 and K. But then as we look at liquid manure, how does it compare? Separated liquid, in these liquid forms, not a lot of difference. But then when we start to look at solid material, the parameters change quite a bit, and you know, between separated solids and solids. So again, my ask of all of you is that when you have sample submittal forms, the more detail that you can put on those forms, the better. It just will help us eventually be able to, not only for us, but for users, to help pull out more specifics about the samples that they're looking at. So what do we see in the future as we look to the future? Well, we have, of course, some opportunities, right? Challenges, opportunities, however you want to look at it. There is differences in terminologies across the country when it comes to manure and manure handling, and that's, I don't think, a surprise to most in this room, but there are differences, and at some point, some standardization will help. We know that we're trying to, you know, through our data intake process and the uploading process of partial zip codes, we're trying to protect privacy. You know, as we get to users, of course, they would love to have as precise a data as possible. And so there's not always a perfect match between the data and what we're able to show and the needs of stakeholders. But there's an opportunity there to keep lending some more specificity to it. And then, as I mentioned, manure sample submission forms are not always filled out properly. Even when they are filled out properly, they don't necessarily give us all the detail that we would love to know about a sample. We have some ideas about how we can lend some more specificity to it. With the swine industry in particular, we know that with the integrated systems that there are some databases as well on farms. And so can we, whether it's matching up with samples in the database or checking or validating what's the predominant manure sample, manure storage type. You know, is there frequent use of additives? I think we have some opportunities to even just go beyond the samples that are coming in to lend some more data behind this. So we continue the construction and user testing of ManureDB in collaboration with our participating labs, and we are still looking for more participating labs, trying to expand the geographical distribution of the samples in there and working on that user interface. It's not pretty right now, right, the user interface, but it does serve the purpose, and it does allow you to start looking at manure database that's in there. Over time, or eventually, this data will be archived on Ag Data Commons as well, looking at some annual uploads to Ag Data Commons as another means of making sure the data is there in some form or fashion for different uses. So this project team is led by Melissa Wilson from the University of Minnesota, and Nancy Bolborman is our basically does everything for us, right, as the grad student on this project. Larry Gunderson with Minnesota Department of Ag and Kevin Silverstein are valuable members of the team. And this work is supported through a USDA FACT grant. So if there are questions about the database, you're more than welcome to contact one of us. The website, as I said, is manuredb.umn.edu. With that, I'm open to any questions you have.
Awesome, thank you. We are open for questions.
Good morning, Erin. Thank you for your talk today. And I'm curious about, you know, that lack of standardization within the reporting laboratories, the form that they fill out. Is there any way, as you sign up participating diagnostic labs, is there any way that you could leverage something to make it uniform, a uniform form? And then my follow-up to that is, then how would that be converted into a uniform database that they would all report into, right? Regardless of where they're from, they would report into a standardized architecture of data, and that we could then pull out, or you could then pull out of.
So part of our approach thus far is we need to create value in this database, because I don't think we're in a position to ask the labs across the U.S. to make huge changes to their infrastructure and their forms until we can demonstrate value to them as well as labs. And so one of our next steps is to build an interface specific to labs so that they can look at their lab samples relative to the whole database. So we need to create value, not only for the labs though, but also for the persons filling in forms, right? Because really, what's the value there? And we can talk about some philosophical values, but we still need to figure out ways to create value to those filling in the forms. So a very simple example, you know, of terminology is the word lagoon. What does that means? Different things to different people. From an ag engineering standpoint, that's a treatment system. For others, that's really just a storage. And so that kind of lack of standard use of a term is just a very simple example of where we might need to make some standardization or even just education, whether it's for those forms or just for people describing their manure storage system. That's one example. But I think right now we're still in that stage of building value in the database.
Erin, question, do you have a way to track if it is from a deep pit or from a shallow pit or flush or pull plug?
So when the samples are, so a lab once a year, the process thus far has been as such. Once a year, you know, a lab will download their thousands of samples that they've analyzed. And in some cases, the person who fills out the form has indicated whether it was liquid, or if the form is as specific as a deep pit, that they've indicated that. Some samples are just, we know it's swine and that's it. So we're at the mercy of what's on a form, both as an option and then what's been selected. So when we have that information, we can add it as a descriptor to that sample. But We have been lucky to have Nancy. She's been willing to comb through the thousands and thousands of samples, because remember, we've been going back in history too to get this data. She's been combing through every single sample. And if there are some descriptors, even in the sample name, that tell us it's a deep pit, she adds that. She has been adding that in manually. So maybe there's some AI down the road to help us do some of that. But that's been the approach so far. That's how we have been getting descriptors so far.
Erin, back here. 2 questions. You showed data from 20-some years ago, so this is not a new thing, or how are you getting that old archive data? And the second question is, how robust is the data set for trace minerals, thinking about, you know, copper and zinc and loading soils, that kind of thing? So
with some of the labs, if the lab has data in their own, what's it called, LIM system, the lab information management system, if their system goes back 20 years and they've been willing to share that data, that's how we got that 20-year-old data. Some labs have changed methods, and so we've been trying to be careful about how we import data. We are trying to track the methods that have been used to analyze these nutrients and these analytes as well. For trace minerals, I kind of liken it to how many times have you ordered those trace minerals on your manure submittal forms, right? It's going to be a smaller proportion of the samples where those trace minerals are reported. Where they are reported or where they're done, yeah, the data comes into the database. But I don't have a specific number for you about what proportion of samples have that yet. But that's, I guess, another area where if we want to build up the database for some of these trace minerals that are gaining more prominence, are there ways to maybe incentivize labs to make that standard? Are there ways to incentivize farmers to incentivize the farmers to ask for those analytes? You know, there's a few different levels that we can look at trying to add value to that data. Pedro?
Erin, you mentioned and showed the difference between book values and the actual database values for many of the outcomes. Can you put in perspective what would be the implications of that difference? So would I be making an error in the number of land that I need to apply manure, or overbuilding into the soil? What is the impact of that assumption of?
Yeah, a couple of potential impacts. Let's say a couple of potential impacts. If your if your nutrient management plan, if you needed to show enough acres to handle the phosphate excreted, and your actual phosphate excreted is half the book value, and if all you had was a book value, you know, you don't. I'm not sure it's twice the number of acres. I can't do that math in my head that quick. But right, in actuality, for a nutrient management plan to show you have enough acres, the number of acres that you would need to handle the phosphorus could potentially be a lot smaller. So you know, there's an economic impact there. The other way where these book values have been referred to in different analyses that have demonstrated, you know, is there too much nitrogen for this region? Is there is the land saturated? And a lot of it is modeling exercises that come from book values of what that concentration of manure is. And I'm not saying that there is no environmental problem with manure, right? But if we have some more specificity to the data, I think we're getting at where and when these problems need to be addressed sooner.
Well, thanks. Let's give Erin a round of applause again.